In our last lecture, we proved measure of a decreasing intersection, which was called that if we have sequence of decreasing sets in sigma algebra, then we prove that measure of the intersection is actually limit k approaches to infinity measure of ek, provided that measure of E1 is finite. But it doesn't hold in case of if measure of E1 is infinity, then this theorem doesn't hold. Then the above does not hold. Okay, to see that, I'm gonna give you a counter example, but one example is enough. So what we can have, so suppose if I have my set of natural number set and sigma algebra is sigma algebra of the power set, and then I'm considering countermeasure, and then so I am considering ek is k plus 1, k plus 2 up to so on. Clearly E1 is containing E2, E1 contains E2, E2 contains E3, and up to so on. And also if we can see that the intersection of all those set is empty set. Why? Because E2 doesn't have 2 1 and E3 doesn't have 1 2, E4 doesn't have 1 2 3, so eventually you can see the intersection is empty set. And then intersection of ek, since it is empty, so the measure of empty is 0, but measure of ek is infinity, so 0 doesn't equal to infinity, hence this theorem doesn't hold. This is the one of the example. You can come up with many other example, but now today our main target is, so we saw that in case of Lebesgue outer measure, so in case of Lebesgue outer measure, we saw that there exists disjoin sets A and B such that the Lebesgue outer measure of A union B is not equal to Lebesgue outer measure of A plus Lebesgue outer measure of B. And it is very easy to see that. So suppose if my A is 0 1, my B is suppose 2 3, then Lebesgue outer measure of A union B is nothing, but this is 3, while the Lebesgue outer measure of A is 1 and Lebesgue outer measure of B is also 1, so A plus B is 2, hence 3 doesn't equal to 2. Okay, we can see that they are disjoint. So this means that Lebesgue outer measure is not a measure. So in general Lebesgue outer measure is not a measure. Okay, but it can be measure in some situation. So the first situation is, we're gonna call it a proposition. So proposition says that let, very important proposition, A B is a subset of R with A intersection B is empty set. They are empty, they are disjoint. Then A union B outer measure is actually A measure plus B outer measure if B is an open interval. Okay, so whenever B is an open interval and they are disjoint, then A union B outer measure is equal to outer measure A plus outer measure B. So proof, since it is very obvious, this is always true. The measure of outer measure of A union B is less than outer measure of A plus outer measure of B. What we need to show? We need to show that A plus B is less than or equal to A union B, right? So we will assume that, so clearly that okay, outer measure of A is finite, because if it is infinite, then the A union B is also infinite, so infinite is equal to infinite. There is nothing to prove, so we just assume that. Now, so in outer measure we always come up with open cover, so we say that let A union B is covered by union of K is equal to 1 up to infinity ik. Now since A intersection B is empty, then the cover of A is nothing but we will just throw out all the stuff that is in B. So ik intersection, so R difference AB, we're gonna throw out everything that is, because if A intersection B is empty, so if something is in A will not be in B, so definitely A is covered in by this interval. So this is nothing but we can rewrite that this is K is equal to infinity, and this is ik intersection, and this is minus infinity to A, okay, and union B to infinity. So then this is nothing but this is, we know that okay, u K is equal to 1 up to infinity, so this is ik intersection minus infinity to A, okay, and then union ik intersection B to infinity. So that's just for your simplification so that you can understand. So again we can rewrite down that this is u is equal to K is equal to 1 ik intersection minus infinity to A, okay, because it has union, so union of K is equal to 1 up to infinity ik, okay, intersection B to infinity, okay. And similarly B is containing u is equal to K is equal to infinity ik intersection AB. So this means that okay, so this is B. So now if this is B, what we can say that this B measure of outer measure of B is less than, the outer measure will be always less than or equal to sum of K is equal to length of the interval, okay. And also since A was this thing, so definitely, so then I can say that okay, outer measure of A plus outer measure of B is less than or equal to sum of K is equal to 1 up to infinity length of ik intersection minus infinity to A, okay, plus sum of K is equal to 1 up to infinity length of ik intersection, so what is this, B to infinity, plus for B it was sum of K is equal to 1 up to infinity length of ik intersection AB. And then because if we just forget about the sum, so length of ik intersection minus infinity to infinity A, length of ik intersection B to infinity, length of ik intersection, this is nothing but this is K is equal to 1 up to infinity length of, this is actually the sum length of ik. Now if we take the infimum, then clearly A plus B, and the right side is nothing but this is outer measure of A union B. Hence we are done. So eventually we got A union B outer measure is a measure of A plus outer measure of B, and we are done. So whenever, so this is the first thing, that if B is an open interval and A intersection B is empty, then outer measure is a measure, okay. So we saw that. Thank you.